CUA 11 Retake. Number 1. If the owner of a go-kart racetrack would like to have a ratio of 2 red racers for every 3 green mini trucks, the racetrack currently has 11 red racers and 21 green mini trucks. Write an equation that she can use to determine X, the number of additional red racers, and that's it. It just asks for the equation. Number 2. Number 3. The time required to empty a tank varies inversely. So time varies inversely as rate. And if a pump can empty a tank in 45 minutes at the rate of 600 kiloliters, I was like, what is KL? Per minute, how long will it take to empty the rest of that? All right, so we're just on part 2. I'll get to part 3 in a moment. We're going to multiply both sides by 600. And that will give us 27,000. All right, and so now we're on part 3, which would be this last bit. So we're going to take our formula. We're going to use the 27,000 over rate. And it says that the rate is 1,000. So I can replace the R with 1,000 and then just figure out what that equals. 27. So that will be 27 minutes is what it would take. Go ahead and try number 4. Number 5, the pressure exerted by the sole of the foot of a person, so pressure inversely varies or varies inversely, so K goes at the top for that, with the area of the sole of the shoe. Each of Darlene's boot has a sole with an area of 23.2 square inches, and the pressure exerted is 5 pounds per square inch. Find the constant, so we got to figure out K. So to get rid of this fraction, I'm going to go ahead and multiply both sides by the denominator. And then that will give me 116 for K. Go ahead and try number 6. Number 7. Marcus was solving the rational equation below. After working through the problem, he concluded that these were the solutions. What would you say to Marcus? All right, so let's go ahead and solve this thing. Hold on, let me do this real quick. I'm going to go ahead, since this appears to be quadratic, I'm going to start by moving everything to one side. So that'll zero out, that'll zero out. So that'll be x squared minus 3x plus 2 equals 0. Now that we're here, let's see if it's factorable. All right, looks like it is factorable. Okay, so once we do that, we're going to separate and solve. All right, so it looks like Marcus is right. However, we have to check for extraneous solutions. And as you can see here, if I plug in the 1 up here, so if I did like 1 minus 1, that would equal 0. And we cannot have 0 as the denominator, so that would be an extraneous solution. So 2 would be the best. So I guess we could tell Marcus that x equals 2 is a solution. But x equals 1 is extraneous. Go ahead and try number 8. Number 9, we're going to go ahead and solve. This one is super easy because look, all the denominators are the same. So if we multiply all of this by b plus 2, it's actually going to cancel all those denominators out. So that'll be b plus 1 plus b minus 3 equals b minus 1. Combine like terms. Oh wait, that was stupid. I don't know why I did that. Ignore. So I'm going to start by subtracting b from both sides. And that would be 1b minus 2 equals negative 1. Then I can go ahead and add 2 to both sides. And that would just be b equals 1. It is not extraneous because if I plug it back in, it works. Try number 10. Number 11, the director of Big Town Aquarium would like to have a ratio of 2 big mouth catfish for every 5 rainbow trout. The aquarium currently has 5 big mouth catfish and 30 rainbow trout. Write an equation that could be used to determine X, the number of additional big mouth catfish. And that's it. Number 12, go for it. Number 13, let's solve for X and then we'll plug it in here. We're going to start by multiplying both sides by the denominator. When you're dealing with fractions, always do that first. Well, almost always. And we're going to go ahead and add X to both sides. And then we're going to divide both sides by 4 to get X by itself. And so now that's our X, but that's not what it's asking us for. It's asking us for 8X. So 8X is going to equal 8 times 5 over 4. And that is just 10. I'm sorry. You could really just put this in your calculator. That would give you 10. My bad. So the answer to that one is 10. Go ahead and try number 14. 15, which of the following X values makes this equation true? Since it's already in proportion form, I'm going to, use cross product. Notice I did not distribute first this time, and that's because we're going to have to do some FOIL. Okie dokie. All right, so this one over here is going to be fine. It's just 11x minus 4. All right, over here we got 2x times x, 2x squared. Then we got 2x times negative 4. So that's negative 8x. Then we got 5, negative 5 times x, and negative 5 times negative 4, which is positive 20. Let's go ahead and combine these like terms. All right, so once we get here, I'll keep going. All right, once we get here, we can subtract 11x from both sides. And we can also add 4 to both sides. And the reason why we're doing that is to get this equal to 0. Now what? I'm going to stop. Both of these have a denominator of x minus 4. So I'm just going to do this. So don't forget when the denominators are the same, right? It's just going to cancel out if you multiply the whole equation by the denominator. Sorry, I made that way complicated. And then we're just going to go ahead and add 5 to both sides. So we get 2x equals, what's that, 16. And then we divide both sides by 2, and we get x equals 8. Try number 16. Number 17. The time required to do a job varies inversely. Oh, let me write that down. So the time varies inversely. So put k at the top as the number of people. Okay. It takes 5 hours. No, how many hours? 7 hours for 5 bricklayers. Bricklayers are the people we're talking about in this problem. And how long will it take 10 bricklayers to complete the job? Okay, so first let's go ahead and solve for k so we can figure out what the constant is. And that would be 35. So our new formula is t equals 35 over n. And we're trying to figure out the time that it would take 10 bricklayers. So t would be 3.5 hours. Go ahead and try number 18. Number 19, before solving the equation below, what value can x not be? X cannot be anything that's going to make the denominator equal 0. So if you solve for x in this case, you'll see that x cannot equal 3, or x equals 3 is the one that it can't be. Number 20, before it. 21, where is the mistake? So, in simplifying this formula, this expression, sorry. All right, step 1, looks like we are factoring by grouping. Okay, actually I'll put this here, make that a negative. Okay, so first step, they factored out an x squared from this first set of parentheses. That looks fine. And then we factored out a 16 from these parentheses. That looks fine. The bottom looks the same. All right, after that, we factored out this part, so that ends up here. And then we're left with this part, which ends up here. The bottom stays the same, looks good. Next part, this one stays the same. This one gets factored. It's a difference of squares, so these factors are correct. Looks good. Bottom stays the same. And then for the last step, where did this go? So step 4 is incorrect because where did the x minus 4 and the x plus 4 go? They don't zero out. They don't just disappear. So step 4 is where the problem is. And the reason is because 3x minus 1 times x minus 4 times x plus 4 does not equal 3x minus 1. Like, these don't just magically disappear. Go ahead and try number 22. Just kidding. We're going to do this one together. My bad. Identify the horizontal asymptote, vertical asymptote, x-intercept, and y-intercept.